Hello, everyone. This is Colleen Milton, and on behalf of cPacket and 451 Research, I would like to welcome you and say thanks for attending today's webcast titled IT Complexity and the New Monitoring Landscape. Leading off the discussion today will be Nancy Gohring, who is a Senior Analyst in Application and Infrastructure Performance at 451 Research. Following Nancy will be Kerry Takenaka, who is Vice President of Product Marketing at cPacket. Just a few quick housekeeping items before we get started. To ask a question, simply type it in the question box on your screen below. We will answer as many questions as we can during the Q&A session, and we'll respond to all unanswered questions via email after the webcast concludes. This presentation and slides are available for download. Finally, please provide feedback at the end of the webinar. And with that, I'll turn it over to Nancy.
Great. Thank you so much, Colleen, and thanks everyone for joining us. Just a quick background on myself, and then I'll dive right in. So as Colleen said, I follow application and infrastructure performance here at 451. So I follow the APM, infrastructure monitoring, NPM, and log analytics markets. And I'm going to be talking to you a bit today about some changes that I'm seeing in the monitoring landscape, largely driven by IT complexity and resulting data volumes that folks are experiencing in terms of data thrown off from their IT environments. So from a very big picture, we're seeing that digital transformation is driving a lot of new technology adoption. And, you know, digital transformation is kind of this big buzz these days. When we ask people about their status in terms of digital transformation, we do find that most organizations are, at the very least, thinking about it. Quite a big proportion of them are actually executing against a formal digital transformation strategy. And as part of those initiatives, they're adopting a whole bunch of new technologies. So right here, this was a survey question we asked just generally about top IT priorities for 2018. You can see that big data related technologies kind of rose to the top. So you've got BI, machine learning and artificial intelligence, big data processing engines, and then a whole bunch of other technologies like SDN, containers, serverless technologies, blockchain. And, you know, the result is that we're seeing very complex application environments. So I'm just going to talk through sort of some of the components that we're seeing organizations adopt more frequently that are really creating this very complex environment that's very different than what we used to see in your kind of traditional monolithic application environment. So you might have containers, and in a container environment, you very often have a lot of containers, so you're managing sort of more things than you used to if you just had a virtualized environment. On an even smaller level, we're seeing more organizations adopt serverless technologies these days, and again, that sort of increases the number of things you have to have insight into in order to drive performance. We're increasingly seeing organizations adopt microservices architectures. This is an image that a company called MyTaxi released a whole bunch of years ago, actually, and it's just meant to show the connection between all of the microservices that make up their application. And in a microservices environment, you often have a polyglot environment because typically teams are given the flexibility to choose the language or the framework that they want that best suits the microservice that they're responsible for. We're also increasingly seeing that applications are being built in multi-cloud environments. So we used to talk a lot about hybrid cloud, and that very often just meant that you had on-prem workloads that worked maybe in conjunction with one infrastructure as a service platform. Now we're seeing organizations sometimes use multiple infrastructure as a service offerings to get either the best price or the best functionality. You also might have a PaaS or two mixed in there. Certainly you've got SaaS, and you might be running a private cloud internally. So you've got a whole bunch of cloud services that may or may not be working together, but still, regardless, need to be monitored. And once you're, of course, relying on the cloud, you're also relying much more frequently on public networks that you have potentially less insight into than you once did when most of your traffic ran over the networks that you owned and controlled. Your applications might be relying on a whole bunch of third-party services, credit card processors, a whole bunch of other services like that that create their own visibility challenges. You very well may be also relying on legacy workloads that might be running in a mainframe. And you've also potentially got a whole bunch of different database technologies within your environment. So it's interesting, we used to see organizations kind of standardize on one database technology. Now we're seeing organizations choose the best technology to suit the needs of the application, which might mean that within an organization, you've got a whole bunch of different database technologies. And the result is a very complex application architecture that has additional complexity in the fact that it might change a lot more frequently than it used to. So not only do you have all of these pieces to keep an eye on, some of these pieces change quite frequently, and that creates events that you need to keep an eye on, and you need to understand how they're impacting application performance. As an example, I just heard Google within the last quarter talk about that they launched something like 4 billion new containers every week. So obviously that's Google, but that creates an environment that continues to change, and that creates additional complexity and challenges in terms of insight. And so what I often see is organizations add more and more monitoring tools to try to get a grip on this complex environment. So you've got network monitoring tools, and actually within that bucket, you might have several, right? You might have something that's doing packet capture. You might have another tool that's collecting, net flow data. You might have another tool that's doing synthetics. You might have multiple synthetic monitoring tools in your environment, one being used by network admins, another being used by ops. You'll have server monitoring tools. You might have an APM tool. You've got RUM. You've got log analytics. That's not to mention, sort of related tools that you might have in place like ITSM and event management and alerting. This, rather than certainly those tools help, but the fact remains that these complex environments are still generating huge volumes of operations data. So here's some examples of some very large organizations, sort of, web-based organizations born in the web, the volume of data that they're collecting. So Yelp, in just 25 million data points a minute. Twitter, 4.8 billion metric writes per minute, and that's up from 3 billion just a year ago. That final bullet about Uber, I think, is also interesting. They recently said that they're experiencing a 20% growth over the last quarter in persisted metrics. So that's just over the last quarter. So, your operation may be smaller than these guys, but I think that as your environment, your IT environment grows in complexity, as it surely will if you're adopting new technologies, you're also going to begin to grow the volume of IT operations data that you're collecting, if you're not already. And so, something to think about here is that that volume is interesting to think about, but, if it's not good data and you don't have sophisticated analytics to pull out intelligence from it, it's not particularly useful to you. So, data quality comes in the form of making sure that you have access to the data you need, and you need the right tools to ensure that you're collecting that data. It also means, data quality also means ensuring that your tools and other back-end infrastructure can handle this growing data volume because, it's pretty clear that you're going to be collecting more and more data from your IT operations. And then finally, data analytics or sophisticated analytics become increasingly important as you collect larger and larger volumes of data. So, no longer can you just sort of look at trend lines to determine what's going on. It's increasingly helpful to have sophisticated analytics that can correlate data across systems and help you understand exactly what's going on and what the root cause of a problem is. So all of this is leading to sort of a reinvention, or at least an examination of monitoring and sort of what the best practice is in terms of monitoring. So, for a long time, there was kind of an accepted set of tools that people harnessed to do their monitoring. So there were NPM tools, APM, infrastructure monitoring, log analytics, and there might be some other tools tossed in the mix that some organizations found helpful, event management. You might have some point tools depending on your application and your specific needs. But it was relatively understood kind of what was available, how each of these tools was defined, how you use them and how they're helpful to you, and who uses them. So which roles within an organization used each of these tools. And today, driven in part by the complexity in modern architectures and the growing volume of operations data, there's a lot of discussion around, what is the appropriate set of tools to use, who should use them, what should these tools be doing. There's just a lot of questioning, a lot of experimentation. And I'll talk just for a couple minutes specifically around what I'm seeing in that regard in terms of NPM tools. So, one of the biggest things that I'm hearing people talk about in NPM is the utility that NPM tools can offer in terms of application insight. So because NPM tools offer insight into communications across different tiers of an application and between all the components that make up a modern complex application, they can often deliver important insight when an application performance problem happens. So I'm hearing a lot of NPM vendors talk about the utility of their tools in an APM context. And I think this is valid. I think that there's a lot of application insight that an NPM tool can offer. And for organizations that have sophisticated NPM tools in place, it's definitely worth looking at ways that roles within the organization that are closely watching application performance might be able to take advantage of those NPM tools. I think there's it's tricky because I'm hearing some from some corners talking about NPM as APM, and the problem is traditionally an APM tool offers code level visibility, which would be an important capability for the set of users that are typically using APM, and most NPM tools are not going to offer code level visibility. So there's still utility certainly around APM tools, but there's also utility in NPM tools in terms of getting insight into application performance. So it's worth thinking about and looking at ways that you can harness your NPM tools in an application use case. So in addition to APM, there's also an emerging role that NPM tools are playing with security, because when it comes down to it, NPM tools are often surfacing the same kind of data that a set of security tools often offers. It's just a matter of the type of analytics that you're running on that data to serve which use case. So I'm definitely beginning to see NPM tools being harnessed for security use cases. They should be well integrated with a set of security tools that's relevant and that can help with that analytics. So So these are two areas that I'm seeing NPM tools sort of being considered and broadening into that I think is worth considering as the world of monitoring is getting some scrutiny here and adjusting to the modern complex IT architecture. So with that, I'm going to hand over to Kerry, who can dive into some more specifics on this topic. So Kerry, take it away.
Thank you, Nancy. So I'm Kerry Takenaka. I run product management for cPacket Networks. And following, I think, a little bit on some of the large trends and transactions and things like that that Nancy spoke about, when we look at modern data centers, we're really seeing the transition happening very quickly to 100 gig and even higher speed networks. We've come off a series of customer meetings just in a very recent time frame where we're seeing customers go straight from 10 to 100, sometimes bypassing 40 and some of the intermediate speeds, just because the economics are there, but also the demand is there as well. Oftentimes there's kind of like a hype cycle that sort of drives initial excitement about some of these speeds, and then the hype sort of dies down, but then what happens is that in the background, the demand has actually been growing and the cost points are being met such that these speed grades are actually happening. So basically what we're seeing at the physical layer is an increase in link speeds, and that's actually translating to an increase in the amount of data that's being generated, because it's not just the speed per link, but it's actually also the number of links themselves. So when you look at things like spine leaf architectures, the number of links in the data center are actually growing. So when we look at that data, there are some interesting observations here. So one of them is that it actually seems like it matters more that you can collect good quality and high volume of data than necessarily the application of the algorithm itself. So what this means is that Google's written a few papers on this. I think there's been other work as well that's related to the fact that if you can get high quality data, then you can make better observations as to the state of your network. In this case, it can be applied to other things as well, whether it's detecting cats and YouTube videos and stuff like that. But essentially, having more data is more useful than having certain kinds of algorithms. So when I speak a little bit here to what this means in the network context, what that means is that the ability to deliver high quality data uniformly and at high resolution can actually lead to more actionable responses. And there are some weaknesses when we look at the network today as to where that's not actually happening in an optimal sense. So one way to look at this in order to kind of level set a little bit is to look at the typical monitoring stack. So the typical monitoring stack is comprised of infrastructure. So this is your switches and routers, which take traffic and move it through either passive optical taps or span ports to a layer of aggregation. And that layer of aggregation, or packet brokers or matrix switches, they move that traffic to a set of tools, typically software tools that can utilize that information and provide better analysis on what's going on. So this is a very typical monitoring stack that we see in most large data center or large enterprise deployments. It's a pretty good monitoring stack, except that when we address it from the perspective of scalability, there are some areas that are a little bit weak. So the infrastructure side is obviously going along very well. So it's low cost and high availability. This is evidenced by the transition to 100 gig and actually also 25 and 50 gig networks. The tap and span layer, the taps are pretty good. They're just glass that you insert inline, so they're extremely reliable, completely passive. Span ports, though, are oversubscribed by definition. So this is an area of weakness where you cannot depend on the quality of the data, or you can't depend on getting the data that you think that you need or might need. The aggregation layer is an area that is becoming increasingly critical, but it suffers from some scalability issues in the sense that, by definition, it's a many-to-one layer. So there's a lot of oversubscription. So the ability to be able to control which traffic comes in and which traffic goes out is dependent on being able to make good decisions on the nature of that traffic in the first place. But oftentimes at this layer, when you want to make these kinds of decisions, there's little visibility. So this is, I think, from a scalability perspective, a critical layer that's lacking in the ability to scale and provide good quality data as we go to higher speeds and more links. And at the tools layer, there are many, many tools, but they suffer from some fundamental limitations about being able to write data to disk, both in terms of the quantity and in terms of the speed, and they're expensive. You know, if your infrastructure could provide you with more analytical tools in the first place, then the dependency on these tools would be reduced, but we do need these tools because the infrastructure itself is not so great at reporting the kind of information that operations teams need in order to act quickly in order to optimize their networks or minimize downtime. So switching a little bit to some numbers, just to get a handle on how hard these problems are. So if we look at just one direction of one 100 gig link, we can see that within 24 hours, there's roughly 1 petabyte of data. So this is just network traffic that we're storing on just one direction of one 100 gig link. That's a huge volume of data. If we go to the other side, we look at a very, very small interval of time. If we look at just one millisecond on one 100 gig link again, that's 12.5 megabytes. So in 1 millisecond, 12.5 megabytes of data traverses the wire. This is more memory than the total amount of resources in many top-of-rack switches. So you can understand where a burst of traffic traveling, on multiple ports is certainly going to lead to packet drops. And if you don't have sufficient resolution, it's going to be extremely hard to understand whether an event like this occurred. So if we map this back to some of the typical monitoring stack elements, so now going from the sort of abstract notion of the infrastructure, the packet brokers, the taps, and the tools to specific elements. So basically the market's comprised of low-end packet brokers, which are the kind of the first set of tools that typically receive traffic, which are, in our opinion, rather feature poor, and the value proposition of a low-end packet broker is essentially that you should save money here and spend money upstream on tools. The problem there, though, is that when you're saving money that's on a granular scale of hundreds of dollars a port, but you have to spend money that is in quanta of tens of thousands of dollars per port upstream, then that's not necessarily the value proposition trade-off that you want to make. Full feature packet brokers are a little bit better, but here that strikes to exactly what I described a little bit in terms of the oversubscription and lack of visibility. So you need to have the right feature bandwidth in order to limit the traffic that goes upstream, and you need visibility in order to make these decisions intelligently. And when you look at the products that exist in this space, you actually don't see very much of either. So there's some caps on the feature throughput that is available, and there's a lack of visibility. So it's kind of a guessing game when it comes to actually sending that traffic upstream. Which traffic should you send? Which links should you filter? How should you load balance? These are very open questions. When we get to MPMD and APM, so these are once again good tools that provide a high degree of visibility, but they're expensive. Many of our customers would like to have some of the features that are available in MPMD or APM at more locations in the network. But because of either performance reasons, because the speeds are so high within their data centers, or the number of links that they want to look at, they're just too cost prohibitive to deploy. And lastly is security. So security is an adjunct to MPMD and APM, kind of like what Nancy mentioned as well, which is that we see that many network performance engineers and security engineers are actually looking at the same kinds of data, but starting from a different hypothesis. And I'll go through some examples of what that means just a few slides down the road. So the cPacket approach has been that we want to push processing to the wire because the oversubscription and bottlenecks that I described earlier that happen primarily in the aggregation layer can be overcome by taking a more distributed approach. So this this addresses the issues with respect to feature throughput, and it also reduces downstream tool resource requirements in a very nice way, because there's oftentimes we've seen this kind of tension between distributed and centralized in compute and in networking, and we believe that right now, in order to address the limitations on the compute side, it's important to go to a more distributed approach when it comes to monitoring on the network. So when we looked at how we could accomplish this distributed architecture, we didn't see that any of the existing technologies were going to fit the bill. So we actually had to build our own ASIC. And this ASIC is basically, really, really good at monitoring the network, and it provides these additional benefits of accuracy, scalability, and coverage. So not only did the distributed architecture naturally lend itself to more efficient processing, but it delivered in terms of data accuracy, and it gave us the kind of coverage that we needed over the network in order to make our customers be able to get better situational awareness of what was going on. So mapping this specifically to elements inside of our solution, so the CView devices are the devices that first receive traffic directly from the network taps and span ports. So this is really the hardware differentiator where the heavy lifting is being performed. So rather than taking traffic and kind of blindly shoveling it to upper layers without having visibility into it, we're taking the network traffic, and we're doing the analysis on each port directly off the wire right there. So this is the core of being distributed. We incorporated elements of packet capture because packet capture and analytics are important for back-in-time analysis, and that's what cStore provides us with. And we needed, of course, visualization to putting our customers in a position where they can detect outliers from the norm in terms of either performance or from a security context, because in the end, you can collect all the data that you want, but having a shortcut to seeing what's different is what's important, and so that's what cClear provides us. And of course, as I mentioned before, we used our custom ASIC at the cView layer in order to provide all of this processing at wire speed continuously on all links. So I mentioned a little bit earlier that performance monitoring and security are the same but different. So this is kind of an 80s reference to Arnold Schwarzenegger and Danny DeVito, but as twins. But oftentimes, performance and security engineers are actually working toward the same sort of objective, but they have a different hypothesis in mind when they start to look at what's actually going on. So one example could be spikes and microbursts. So a performance engineer would tackle this from the perspective of it being a capacity issue, whereas a security engineer might see that this is attack probing. This is where the spikes or bursts are coming from, and they would want to know where they're coming from. A behavior like SYN-to-SYN ACK ratio is greater than 1. So once again, a performance engineer says, well, maybe my server is down, but a security engineer says this might be some sort of DDoS attack because it's the ratio of successful connections to unsuccessful connections. Next would be growth in response time. So once again, performance engineer says maybe a server is loaded, whereas a security engineer is looking at attributes of possibly a reflection attack. And finally, looking at packet traces, this is an integral component that performance engineers use in order to troubleshoot application performance, whereas a security engineer looks at these from a security forensics point of view to understand the nature of the threat beyond maybe what a security device can indicate in terms of a threat happening at a particular time or a particular location or involving specific hosts. So this is basically the deeper understanding of what's going on. So lastly, one thing to touch upon is cClear-V. So cClear, as I mentioned earlier, sits on top of our monitoring stack and basically integrates all of the information across all of the different data sources, the cView devices, cStore, as well as pulling in data from any other data source so that it can be displayed in one place. And we can do some predictive analytics. We can display the KPIs. But what was really important about cClear-V is the evolution from our cClear appliance, was to take into account this growth in the amount of data that we saw occurring and customers' requirements to both capture that data, but also be able to provide it in a uniform, high-resolution way to other systems that may or may not want to operate on that data as well. So this is, data lakes, I think, are one aspect of it, but being able to structure the data in such a way that it can be efficiently pulled out for analysis is probably better. Just throwing everything into a big repository of data and hoping that applying an algorithm to it is probably not the right approach. So cClear-V is a way to basically distribute the data collection so that we can make sure that this high quality data that we've collected on our cView devices is available and stored correctly, but then can also be merged into other algorithms for other correlation in other ways. So basically that kind of puts the top on the way that we look at the monitoring stack and the importance of being able to collect the data in the first place, but also be able to access that data. Because if the data quality is not good, as Nancy mentioned, if the data quality is not good and the data quality is not uniformly collected across the network, then that leads to false positives and false negatives. And I think we'll agree that that's probably not a good thing to have happen. So that's it on my side.
Thank you, Kerry. It's now time for our Q&A session. As a reminder, simply type in your question in the box below and we will get to as many as we can. We already have a few, so let's get started. This is actually for both of you. Are you seeing companies get rid of APM altogether and rely only on their network performance tools for app insight?
I can jump in on that one if you don't mind, and then Kerry, I'm sure you'll have some comment there. I'm not seeing folks get rid of APM altogether, and I wouldn't recommend it. I think that APM tools offer some important insight that you're not going to get elsewhere. What I am seeing is, I'm hearing from organizations that are frustrated with the growing costs of using APM as their environments grow. So, for example, late last year I talked to this guy. He was a CIO of, I think it was a state government agency, could have been a city government agency, so obviously, budget constrained. And they were getting a lot of utility out of APM, but definitely couldn't afford to deploy it across all of their application environments. And what they were doing was, they basically were paying for a number of agents in essence. That's kind of the way they were thinking of it. And then if they had a performance problem in an app or some area, they would deploy the agents there, try to figure out what the problem was, and then basically wait till a performance problem somewhere else, redeploy those agents to try to get insight into what was going on when problems were occurring. So, in other words, I think people are getting really creative in terms of trying to keep their APM costs down. And so, one way to do that would be to potentially deploy your APM agents kind of sparsely across your environment, and then try to supplement that insight with another tool that maybe you're already using or that might cost less, and that you can deploy everywhere across your environment and get some insight into application performance. And so one option for doing that would be to use some sort of NPM tool that you're already using, or that you can deploy everywhere and get some of that insight, even if it's not quite as detailed down to like code level insight like an APM tool offers. And that's just a way that people are thinking about controlling APM costs. So that's what I'm seeing. Kerry, I don't know if you have different perspectives.
No, I completely agree. I mean, I think that in order to get really detailed information on specific application performance, there's really no substitute in the end for deploying agents and being instrumented all the way from the data center to the end user. At the same time, there are a lot of practical considerations there. Deploying APM is not so straightforward. Sometimes it involves integration with the code base, so it's very customized. It can slow down deployment of new features due to that high degree of integration. At the same time, there are macro network performance levels that can be monitored in order to maybe not give the same level of insight as to what's going on the APM side, but can provide important information that can still help troubleshoot and look at, sometimes it's just useful to be able to view network metrics at the top level because changes in application behavior, either due to bugs in the application or due to security issues inside the network, they definitely do impact at the macro level as well. And sometimes it's not necessary to drill immediately down to the APM agent, where basically you're applying the microscope before you've been able to get some perspective on the problem. And so I think that combination of being able to get network-wide visibility in conjunction with intelligent deployment of APM makes a lot of sense.
Great, thank you. The next question is for you, Kerry. What kind of security tools would need to be used in conjunction with something like cPacket to serve the security use case?
Okay, that's a good question. We actually didn't necessarily intend to build a security forensics tool. It was actually something that our customers came to us with because they needed actually more context around specific issues as they occurred in the network. So one example is a high volume transaction company that deploys a pretty good set of firewalls across their network. And those firewalls would report information such as if an attack or an incident happened at some time T with a host H involving some IP addresses A and B. And the problem with that information was that although the incident or event had been logged, there wasn't enough information for the InfoSec people at this company to be able to drill down further and understand what level of exposure was actually going on inside their network. So they basically integrated, they had already deployed our CView and CSOR devices throughout their network, and they integrated the event time data that was coming off of these firewalls with the detailed performance monitoring and packet capture data that was available in our devices in order to be able to package all the information up in a way that their InfoSec engineers could now get the full context over the problems. So resulting from this kind of interaction with this customer and this particular firewall, that led us to integrate with other devices such as Cisco's Firepower and other firewall devices, which is just a really common deployment method that we're seeing that gives both the protection that customers need as well as the context and detailed performance data and packet traces that they need in order to take the investigation one step further.
Great. Do we have another question? Oh, go ahead.
We do. One just came through actually right now. And this is for either or both of you. How are the companies dealing with IT operations data overload? Are there best practices around only collecting the right kinds of operations data?
Kerry, do you want to take a stab at that?
Sure. So I think one of the things that we hear a lot about is from customers is that although they want to collect as much data as possible, once again in the hopes of being able to analyze it and get some sort of correlation or causation out of it, there is more and more a desire to understand what happens after that data has been collected and turn it into something actionable. And one of the most actionable ways to extract meaning from this data is to detect the outliers. So, what this means in order to detect an outlier, of course, is that we need to understand first what is considered normal or baseline performance. So whether in a performance anomaly detection perspective, which is just to understand that servers as a group tend to behave with response times that look like X. So if there's deviation, let's say 2 standard deviations away from X, then that's a server that seems to be operating anomalously. So that needs to be investigated. So that's one aspect. Another thing that is actually sounds like a very old-fashioned network performance issue, but it's capacity planning. So capacity planning when we look at these high-speed networks, once again, we think that connectivity is free, but actually what happens is that across the wider area network, connectivity is not yet free. It's actually expensive. So being able to take good quality data and lots of it at sufficiently high resolution leads to better application for capacity planning and what we would call today more something like predictive analytics. But ultimately, it's still capacity planning. So I think that there are a lot of applications for getting high quality data ingested, but in the end, what customers are actually looking for is to somehow extract the aberrant events from that data and then be able to trace back and look at the entire data set if necessary in order to get more context if necessary.
Yeah, that's actually a good point. I think that a lot depends on the data and sort of where it's coming from. So I do see some efforts, particularly from some really large organizations that are kind of drowning in data, to just make sure that the way their applications are, say, instrumented, or the tools that are in use are actually collecting useful data and not just, being set up like a fire hose to suck in a ton of stuff that's not being used. So I think that I am seeing some organizations kind of step back and examine what they're collecting to make sure it's actually something useful. But on the other hand, like Kerry said, there is an awful lot of data that you just kind of don't know. So you need to, collect it in some fashion. And then there's increasingly a lot of tools available that allow you to, collect data, analyze it, very quickly, maybe close to the ingest point, so that you don't have to actually store this huge volume of data, which is often where costs get unwieldy. So I guess, in answer to the question, there are definitely some best practices, and it kind of depends on, what the source of the data is, what exactly you're looking at. But there's definitely, best practices and also tools that can help deal with this deluge of data.
And we have one final question. How important is MI or ML, and do you use it?
I guess I'll take this question. So definitely, I think AI and machine learning are, first of all, they're basically terms that refer to computational statistics. And, our customers have asked us, how can we apply specifically more machine learning probably than AI in order to help extract these outliers. So the way that we've been doing that is by leveraging, our good quality data and being able to apply algorithms that maybe can't be applied when the quality of that data is not so uniform. So once you have high quality data, then you can go into fields such as signal processing and information theory and get some pretty good results. But I think that there's a lot of maybe hype or buzz around these terms, but it's not always easy to formulate the problem that we want to solve in terms that can be answered by AI or ML. So because what's important here is creating the right question so that we can apply the right technique in order to answer that question. So it's looking at the toolbox, but we need to know what the job at hand is first. I think that in anomaly detection, it's relatively straightforward in order to look for these outliers. But as I sort of facetiously mentioned with cat detection in YouTube, if that's the problem that you want to solve, then you can construct the training data sets and try different algorithms in order to come up with what yields the best result. But oftentimes, the reason why people become experts at operating their networks is that they can't extract in a very concise manner exactly what it is that is wrong with the network. They become masters of complexity, and when they look at their network, they just know it.
Yeah, I think I'd probably echo a lot of what Kerry said, and more generally speaking, I do get a lot of questions about machine learning and AI, and I'm increasingly seeing it being harnessed for a number of use cases, and I definitely think it can be useful in sort of sorting through the huge volumes of data that people are collecting. So, yeah.
All right, well, thank you so much, Kerry and Nancy. That concludes today's webcast. As a reminder, the on-demand replay will be available on Bright Talk soon. On behalf of cPacket and 451 Research, thank you so much for attending and have a great day.